Today I'm turning my attention once more to these LiFePO4 cells, which I hope will replace my lead acid battery bank here in the solar shed. Now I'm pleased to say that of the 12 that I was kindly given, well, all 12 seem to be working quite well. They all turned up with, well, varying initial voltages. One was particularly low, just over 2 volts, but I've slowly charged them up and I've put an average of 68 amp hours into each and every one, and I've left them for a month to check that they're not self-discharging, and as you can see, apart from a slight difference there on that second cell, they're all sitting at 3.34 volts after 1 month of just sitting there doing nothing. So I'm really pleased. I seem to have 12 good cells here. And because I now know I've got 12 good cells, that means I can definitely put them into 4S3P with 4 cells in series and 3 in parallel. Now my plan has always been to parallel up these cells, so these 3 on the left hand side, these 3 in parallel will have all their positives and negatives well, connected together, and that of course will be the same case for all of the 4 cells in series, or all the parallel sets. But of course I'll also need to connect each of these parallel sets together, so the positive of that one will go to the negative of that one, and to try and make things even, well, we'll attach to the opposite end of the group. So that one will go to that one, and that one will go there, meaning I will get my most positive point here and my most negative point here. But today I've been thinking about how I'm actually going to connect these cells together, so let me show you the idea I've come up with. So let's take these 2 cells as an example. If these were connected in series, we're going to have to move them sort of that way. The most negative point is over here. The positive will need to connect to the negative of this cell, and this will be the most positive point over here. So I need something that will span this gap here, be able to carry a good amount of current, and be able to be screwed down into these terminals. And looking around the shed, I found something that might just do the job. Now, I was lucky enough to find some offcuts of copper pipe here. They're quite fairly short lengths, but still too big for my small bench here. This is a standard sort of copper pipe used in the UK for water and gas. And if I get some verniper calipers here, what sort of size is this? This is 15 millimeters in diameter, and the copper's not hugely thick, but it'll definitely carry some current, won't it? So I've got an idea about cutting this up into sections and making this into, well, the sort of bus bars or straps between my LiFePO4 cells. So earlier today I very carefully measured the gap here between these 2 posts, making sure to keep my calipers here away from the other terminals, and I measured 53 millimeters between the 2 of them there, and that allowed me to make a little design. And this is what I came up with, or these 2 parts here. It's a 3D printed mould, for want of a better term. I'm hoping to squash the copper pipe between these 2 moulds and make something that resembles a proper strap that I can use. So these 2 moulds here, I put a little marker on there to mark the centre. I'm not sure whether I'll need that, and it's also got 2 holes there which should be that 53 millimeters apart. Perhaps I can use that as a guide for my drill. But yeah, I thought there's a chance I might be able to squeeze that pipe into something flat. Well, flat with a bit of a hump in it. Let me show you my thoughts. So if I measure this mould, I think I made it 80 millimeters wide. Yes, I did. I'll just tighten that up and then get my pipe, put the one end over there and try and make a decent scratch on that side. Yes, I can see that there. And then I bought myself one of these pipe cutters, and hopefully if I align that cutting blade there with the pipe cutter, and these have to go a certain way round, and we'll just spin the pipe, hold the cutter. Is that enough? Have I done enough? Yes. Perhaps didn't need to go around quite that many times. There's my piece of pipe, and the end of that is, well, not very sharp at all. That's quite impressive. Which side did I cut? That one? Anyway, I'm really impressed with that. That's really useful and makes this whole job very easy. Now I have my 80 millimeters of pipe. I've got 2 sections of mould that should be the same length. Now I just need to squash it. And to do that, I'm intending to use this vise. The vise of knowledge, I think Big Clive calls it. And if that all fits in there quite nicely, will this work? Well, I'm hoping it will. So let's just tighten that up and make sure everything's in the centre. Yes, it is. And then let's see if I turn it around this way, perhaps. How easily can I squash this pipe? It's definitely squashing in the middle. But as we end up getting to squash more pipe, is this going to be too difficult? What will this vise of knowledge release? Oh, do you know, it's actually working. At least I'm squashing the pipe, and the 3D printed mould is not yielding yet. We're getting there, but it's getting quite hard. Right, I think that's about as tight as I can get that. Let's see the results. Let's tighten that, loosen that off, sorry, and see what we've made. Do you know, I don't think that's too bad. I'm pretty impressed. I might be able to squash that again, because looking at that, I think there's some room there. I might give that a second pressing and see what we find. Could do with something with a bit more leverage to get on there. And possibly bolting this down might make it easier, but I'm pretty pleased with the result, I have to say. That 3D printed mould has worked superbly well. I thought there was a good chance that might crumble more than the copper, but luckily copper's quite a soft metal, so do you know what? I'm quite pleased with that. I think that might work. All I need to do is drill a hole in, well, 2 holes, one in each end, and that might just work. Now, if I had thought about this a bit more, this was a bit of a rush job this morning, then actually I could have used the mould to clamp down the copper pipe, my new bus bar or strap into here as well and then drill the holes. But I didn't make the mould as wide as the copper has ended up being. I've obviously, well, I didn't do a calculation because 15 millimeters, 2 pi r, yeah, that's 2 times 3.1 times, well, 7.5, 2 pi r. Yeah, that's more than 20 mil, and I only made this 20 millimeters, sorry. So, yeah, if I'd have made this a bit taller, then I could have used this as my way of drilling as well. So, well, I'll try another way. I'll drill some holes in here and we'll see if it will strap my batteries together. So using the mould as a guide, I've drilled 2 holes in this copper strap and they look about right. I've got some hex bolts here with a washer. Now these are stainless steel and I was a bit concerned about that because it's not the best conductor, but of course the bottom of this strap here is going to connect directly with the contact there on the cell, so I'm not too worried about that. There won't be any current going this way. Now I did notice that my standard screwdriver here, if you turn the bit round the wrong way round, is exactly the right size hex nut here for this M6 bolt. So given that, I should be able to just tighten that up in there, and that works reasonably well. I won't tighten it down fully. This can go on that side, and there we go. We have, once they're tightened down, a working connector between these 2 cells, a pretty high current strap for these LiFePO4s. Now I need to consider the connections between my parallel cells. So if I put this one on top of here like that, do I need such a high current connection between the common positives here and the common negatives? These connections between the cells in parallel, well, do they need to be as high current, or should in fact I be fusing them like I have in my lithium ion 18650 7S20P pack? With LiFePO4, do I need to be as concerned about one of these cells going south, going short circuit, something like that, and the cell next to it dumping all its energy into it? And that's a question I'd really like some feedback on. Do I need high current connectors here, or should these be fused? If you've got any experience or thoughts about that, please do put a comment down below. Hopefully you've enjoyed this video. If you did, give me a thumbs up, subscribe down below, comment if you can, and I will see you next time. Thanks for watching.